Hello, my dear students. Welcome to the fourth lecture of electrostatic potential and capacitance. In this lecture, we'll discuss the MCQ questions of conductors and their behavior in electric field. So, moving to the first question from MTG fingertips book. If a conductor has a potential, that means that is not equal to 0, and there are no charges anywhere else outside. That means what it is saying, conductor is having some potential and there are no charges anywhere else outside it. Then which of the following options are correct? There must be charge on the surface or inside itself. There cannot be any charge in the body of the conductor. There must be charges only on the surface, both A and B. Okay, so here assume that we are taking a conductor. So this is a conductor which is having let a conductor, and let it be its center. And here what it is saying, suppose this conductor is having some potential V. Clear? So we know that when you place a conductor in a external electric field, when you place a conductor in an external electric field, then net electric field inside the conductor is 0. And it also says us that net charge enclosed inside the conductor is also 0. Clear? That means this conductor will behave as a equipotential surface. This conductor will behave as an equipotential surface. Clear? And so the first option, what it is saying, there must be charges on the surface or inside itself. That means over here what it is saying, there must be charges on the surface. It is saying that charges must be on the surface, and also it is saying that inside. So inside it is 0, so how can it be there? So that means this is wrong. Similarly, second option, there cannot be any charge in the body of the conductor. It is what it is saying is that there cannot be any charge in the body of the conductor. That means no charges will be present. Suppose if I will be giving a charge Q to this given conductor, then those charges will not be there in the body. That means not only inside, also on the surface. Clear? So that means all the charges will reside only outside the given conductor. Clear? So this is also wrong. Why? Because if we give some charge to this conductor, that means if it is some positive charge, then the charges will reside only on the outer surface of the conductor. Outer surface, that means on the body itself. Clear? Charges will reside only on the surface, that means outer surface of the given conductor. So here that means this option B is also incorrect. There must be charges only on the surface. Charges will reside only on the surface. That is correct. So, and option D is saying both A and B are correct, so that is also wrong. So here in this particular case, option C is correct. So remember one thing, whenever you give some charge to a conductor, that means if it is a conducting body, then charges will distribute automatically on the surface of the conductor, and electric field inside the conductor will be 0, net charge enclosed is 0, and the conductors will behave as an equipotential surface. That means anywhere on the surface as well as inside, potential will remain constant. Clear? Next, moving to second, that means question number 41 of MTG book. Which of the following statement is false for a perfect conductor? It is saying about a perfect conductor. Okay. The surface of a conductor is an equipotential surface. Surface of a conductor is an equipotential surface. Yes, that is correct. That means just before that we just told that V should remain constant. V is constant not only on the surface but also inside. Inside also potential remains constant. Next, second, the electric field just outside the surface of a conductor is perpendicular to the surface. That means if we draw the electric field lines, that means, or you can say in normal case, suppose if I'll be drawing any electric field, or suppose okay, fine. So electric field will be that here. Suppose if I'll be placing this given conductor in an external field, let me draw the field lines like this. Then here in this particular case, what will be the nature of these field lines? The nature of these field lines will be here. Let me take this picture. If I'll be taking this one here, if I'll place it over here, suppose, then in that particular case the field lines inside, no field lines will be there inside the given conductor. Here there will not be any field lines inside the conductor. Clear? And here also there will not be any field lines inside the given conductor. No field lines inside. Clear? So that means what? That means over here, what will be the nature of field lines at that particular point? Here it makes an angle 90 degree. Here also it is electric field lines are perpendicular to the surface. Here in this particular case, field line is not perpendicular, it is making some angle. So how the field lines over here, it should be like this. It should be perpendicular. That means the field lines must enter the surface. It should be like this. Should be the nature of field line. That means over here it must be perpendicular. Here also similarly here also, if we will try to draw, then that field line must be like this. Clear? It must enter perpendicularly and must exit perpendicularly. Must enter perpendicularly and exit also. Per here it is just touching the surface. That means there will not be any particular change. That means here you can also say the field line must be perpendicular. That means it must enter the surface like this, perpendicular, and it must exit perpendicularly from the surface. So this should be the nature of field line. So just outside the perpendicular surface, that is also correct. Next, the charge carried by a metallic sphere is always uniformly distributed over its surface. That is also correct. Why? Because we have already discussed that if you give some charge to a conductor, that means these charges will reside only on the surface and they will distribute themselves uniformly on the surface. यहाँ पे यूनिफॉर्म डिस्ट्रीब्यूशन होता है. क्लियर? अगर ये कंडक्टिंग बॉडी है, so ये वाला करेक्ट है. और ऑप्शन डी, what it is saying, it is none of this. That means here false statement is D. So here we'll choose option D. Next, in question number 42, consider two conducting spheres of radii R1 and R2 with R1 greater than R2. So there are two conducting spheres. First one, let us consider R1. R1, let me draw the bigger one. So here let it be R1, and another sphere will be taking, let it be R2. R1 is greater than R2. Clear? So here in this particular case, if this is the center, so let it be R1 and here it is R2. Okay, R1 greater than R2. If the two are at the same potential, both are having potential V, it is having potential B, it is also having potential B, and the larger sphere has more charge than the smaller sphere. So assume that the sphere 1 is having charge Q1 and sphere 2 is having charge Q2, and the condition is that R1 greater than R2, that is given, and also Q1 greater than Q2. Clear? Larger sphere has more charge than the smaller sphere. Then which of the following is correct? The surface charge density of smaller sphere is less than that of larger sphere. Surface charge density of smaller sphere. Here let us assume the surface charge densities of the spheres are sigma 1 and sigma 2. Clear? So in the first case, what it is saying is that surface charge density of smaller sphere is less than, that means sigma 2 is less than sigma 1. And the second case, the surface charge density of smaller sphere is more than that of large sphere, that means sigma 2 greater than sigma 1. Both spheres have same surface charge density, that means sigma 1 equal to sigma 2. Clear? Or okay, that is, and last is none of this. So we have to prove which one of the three to be correct. or if neither of them are correct, then it means we will check none of these. So here in this particular case, what the first condition they are saying is that potentials are same, v1 equal to v2 equal to v, both are having same potential. That means here in this particular case, अगर मान लो कि ये जो स्पीयर है, पहला वाला स्पीयर, दिस इज द फर्स्ट स्पीयर, दिस इज फर्स्ट स्पीयर एंड दिस इज सेकेंड स्पीयर। क्लियर, 1 2 से हम इसको इंडिकेट कर लेते हैं। तो फर्स्ट स्पीयर का पोटेंशियल कितना होगा? पोटेंशियल ऑफ द फर्स्ट स्पीयर, लेट इट बी के q1 divided by r1। clear, and potential of second sphere will be how much? It will be k q2 divided by r2। clear, so k will get cancelled out, so from here what you can write, q1 upon q2, ratio of q1 q2 will be equal to simply r1 upon r2। clear, तो यहाँ पे ये हमें मालूम पड़ रहा है कि डेफिनेटली r1 अगर r2 से ज़्यादा होगा, दैट मीन्स q1 विल बी ग्रेटर देन q2। क्लियर, ओके। सो अभी अगर हम सरफेस चार्ज डेंसिटी की बात करेंगे, क्लियर, तो ये तो एक रिलेशन हमें मिल रहा है यहाँ पे। क्लियर, सिमिलरली रिगार्डिंग सरफेस चार्ज डेंसिटी, सो इफ आई ट्राई टू राइट डाउन द सरफेस चार्ज डेंसिटी ऑफ द फर्स्ट स्फीयर। क्लियर, तो सरफेस चार्ज डेंसिटी का जो फॉर्मूला हमारा क्या रहता है? सरफेस चार्ज डेंसिटी का जो फॉर्मूला रहता है, सिग्मा इज इक्वल टू क्यू अपॉन गिवन एरिया। एरिया यहाँ पे ये स्पीयर है, तो स्पीयर का सरफेस एरिया हमें लेना है 4 पाई r square। clear, charge that is distributed on the surface, that is q1 divided by surface area is 4 pi r1 square, and similarly surface charge density of the second sphere will be how much? It will be simply q2 upon 4 pi r2 square। clear, okay। So here also if we'll take the ratio of both, clear, here in this particular case if we'll take the ratio of both, then sigma 1 upon sigma 2 will be nothing but q1 upon 4 pi r1 square all divided by q2 upon 4 pi r2 square। so 4 pi will cancel out, so that means over here it will be q1 upon q2 all into r2 square upon r1 square। but here in this particular case the ratio of q1 upon q2, आप कोई भी फॉर्मेट में आप लिख सकते हो, बट ये इसको अगर हम मान लेते हैं कि इक्वेशन 1, सो इसका वैल्यू अगर हम यहाँ पे पुट करेंगे, सो इट विल बी r1 अपॉन r2 होल इनटू r2 स्क्वायर अपॉन r1 स्क्वायर। सो r1 r2, एक r1 r2 यहाँ पे कैंसिल हो जाएगा, सो फाइनली इट विल बी r2 अपॉन r1। क्लियर, सो फाइनली तो स्टैंडर्ड रिलेशन हमें यहाँ पे मिल रहा है कि चेक करना है कि कौन सा ज़्यादा हुआ। सो सरफेस डेंसिटी ऑफ द फर्स्ट वन सिग्मा 1 अपॉन सिग्मा 2, व्हाट वी आर गेटिंग r2 अपॉन r1, बट कंडीशन हमारा क्या था? r1 इज ग्रेटर देन r2। क्लियर, यहाँ पे क्या है? r1 इज ग्रेटर देन r2, दैट मीन्स यहाँ पे डिनोमिनेटर पार्ट जो है ये हमारा बड़ा है एज कम्पेयर टू द न्यूमरेटर। क्लियर, दैट मीन्स दिस रिजल्ट वैल्यू, इसका जो ये जो रेशियो या फिर ये जो डिवीजन है, ये इसका वैल्यू क्या है? इसका वैल्यू हमें लेस देन 1 मिलेगा। क्लियर, इट शुड बी लेस देन 1, दैट मीन्स हियर इन दिस पर्टिकुलर केस द वैल्यू, और यू कैन से ओवर हियर, or else we can write it like that sigma 2 upon sigma 1 will be equal to r1 upon r2, and this particular value which is really greater than 1, if it is greater than 1, that means over here in this particular case this particular value, if it is greater than 1, that means sigma 2 will be greater than sigma 1। यहाँ पे क्या होगा? surface charge density in the smaller sphere will be greater than the surface charge density in the larger sphere। क्लियर, तो ये वाला चीज़ें हमें यहाँ पे ध्यान में रखना है। क्लियर, कि ये जो वैल्यू है अप्रोक्सीमेटली आप मान लो कि ऐसे भी मान लो कि 1 से ज़्यादा होगा तो 1.5 मान लेते हैं, दैट मीन्स यहाँ पे सिग्मा 2 क्या होगा? सिग्मा 1 से ज़्यादा होगा। क्लियर, सो दैट मीन्स विच ऑफ द फॉलोइंग ऑप्शन इज करेक्ट? सो सिग्मा 2 ग्रेटर देन सिग्मा 1, सो ऑप्शन बी इज द करेक्ट। Okay, moving to question number 43. Two metal spheres one of radius r and other of radius 2r, both have same surface charge density sigma. Clear? So here in this particular case, consider two metal spheres. Uh, Metal sphere, let it be having radius r and other one is having radius 2r. Okay, so here in this particular case, so here in this particular case, okay, we'll take three figures, similar figures of this one. So here what it is saying, this sphere is having radius r and this sphere is having radius, let it be 2r. Here also r and here 2r, here r and here also 2r. So here in this particular case, having same surface, initially they are having same surface charge density. If they are brought in contact and separated, initially this is the system. Clear? And after some time, what they have done, they have just brought them in contact. So let me take and make them in contact. So right now they are in contact. Clear? Right now they are in contact, and after that what they did is contact and separated. Then after that sometime they make them separated. Okay. The new surface charge density on each of the spheres are respectively. So what it is asking, if the new surface charge densities, let it be sigma 1 and let it be sigma 2. Clear? So here in this particular case, so what is the standard relationship? That means what they are, you have to express the new surface charge density in terms of the original one. Clear? तो ये हमें यहाँ पे करना है. तो इनिशियली यहाँ पे जो गिवन इन्फॉर्मेशन है, तो यहाँ पे उसी के अकॉर्डिंग यहाँ पे हमारा जो इनिशियल केस में क्या है, सरफेस चार्ज डेंसिटी ऑफ बोथ आर सेम सिग्मा. दैट मीन्स इसका जो सरफेस चार्ज डेंसिटी है सिग्मा और इसका जो सरफेस चार्ज डेंसिटी है सिग्मा, ये दोनों सेम है. लेकिन इसका सरफेस चार्ज डेंसिटी कितना होगा, दैट सरफेस चार्ज डेंसिटी ऑफ द स्मॉलर स्फीयर विल बी, अब इस वाले पर्टिकुलर केस में हम एज्यूम कर लेते हैं कि सरफेस चार्ज डेंसिटी भले ही सेम हो बट चार्ज प्रेजेंट ऑन द सरफेसेस माइट नॉट बी सेम. तो यहाँ पे इसका मान लो कि Q1 है और इसका चार्ज मान लो कि Q2 है. दैट मीन्स एंड ओवर हियर ये वाला केस में यहाँ पे हम एज्यूम कर लेते हैं कि इसका जो चार्ज है यहाँ पे लेट इट बी Q1 प्राइम और इसका चार्ज मान लो कि यहाँ पे फाइनली Q2 प्राइम यहाँ पे आएगा. क्लियर? अच्छा, सेकेंड थिंग यहाँ पे और एक इम्पोर्टेंट फैक्टर है, जब हम दो स्पीयर्स को कॉन्टैक्ट में लाते हैं तो उसमें एक चीज़ जो है वो कॉमन रहता है या फिर कांस्टेंट रहता है. क्लियर? और वो क्या है, वो है उसका पोटेंशियल. क्लियर? अब इसका पोटेंशियल और इसका पोटेंशियल, दोनों का पोटेंशियल वहाँ पे क्या होगा, सेम होगा. क्लियर? दैट मीन्स आफ्टर सेपरेशन ऑल्सो देयर पोटेंशियल विल रिमेन सेम. तो सेपरेशन करने के बाद भी क्या होगा, उनका पोटेंशियल वहाँ पे कॉमन पोटेंशियल मतलब सेम रहेगा. क्लियर? अच्छा, तो फाइनली अभी जो पहला जो स्टेटमेंट है उसमें बोला है कि सरफेस चार्ज डेंसिटी यहाँ पे इनिशियली सेम है. तो उसी के हिसाब से हमारा जो पहला वाला स्फीयर है जिसका सरफेस चार्ज डेंसिटी होगा Q1/4 r स्क्वायर, और सेकेंड स्फीयर जो है उसका सरफेस चार्ज डेंसिटी होगा Q2/4 pi 2r square. So 4 pi will get cancelled out. So finally Q1/Q2 will be equal to r square upon 4r square. So r square will get cancelled out. So from there we can write Q2 will be equal to 4 okay, Q2 will be equal to 4 Q1. So this is one standard relation we are getting when the surface charge densities are equal. Okay, next here in the second case, in the second phase, that means यहाँ पे हम उन दोनों को contact मिला रहे हैं, we are making them in contact and after that we are separating them. So in the process, in this process the potential remains same. That means स्पीयर 1 का पोटेंशियल और स्पीयर 2 का पोटेंशियल ये दोनों सेम रहेगा. क्लियर? तो स्पीयर 1 का जो पोटेंशियल है वो कितना है, यहाँ पे फॉर्मूला हम अप्लाई कर लेंगे. सो के इस वाले केस में तो यहाँ पे इसको हम, ये जो है वो सेपरेशन होने के बाद ये सिस्टम हुआ. क्लियर? तो सेपरेशन होने के बाद हम एज्यूम करें कि जो स्पीयर 1 है उसमें चार्ज कितना है Q1 प्राइम. क्लियर? और उसका रेडियस वही r है. क्लियर? और सेकेंड स्पीयर जो है उसका जो पोटेंशियल कितना होगा, अगर उसमें चार्ज Q2 प्राइम रहा तो इट विल बी K Q2 प्राइम डिवाइडेड बाय रेडियस इज 2r, so 1r got cancelled, K also got cancelled. So finally here what we'll get a relation Q1 prime upon Q2 prime will be equal to how much? So Q2 prime will come this side, that means it will be 1 by 2. That means from there what we can write, so Q2 prime will be equal to twice of Q1 prime. So this is another relation what we are getting. Clear? अच्छा, तो इस वाले पर्टिकुलर केस में अगर हमें ये रिलेशन मिला तो इसके बाद जो नेक्स्ट स्टेप होगा, यहाँ पे सरफेस टेंजेंसी तो फाइनली हमें निकालना है. क्लियर? तो सरफेस वन का जो जो आपका फिगर वन, जो आपका स्पीयर वन का सरफेस चार्ज डेंसिटी कितना होगा, सिग्मा वन विल बी इक्वल टू Q1 प्राइम डिवाइडेड बाय 4πr². क्लियर? ओके, सो हियर इन दिस पर्टिकुलर केस, अच्छा, Q1 प्राइम को हम उसको कैसे लिखेंगे इन टर्म्स ऑफ Q. क्लियर? मतलब Q1 के टर्म्स में हम उसको कैसे लिखेंगे, या फिर मान लो कि हमें सरफेस चार्ज डेंसिटी सिग्मा 2 अगर लिखना है तो उसका वैल्यू कितना होगा, Q2 प्राइम डिवाइडेड बाय 4π रेडियस इज 2r². तो ये होगा. बट यहाँ पे Q1 प्राइम या फिर Q2 प्राइम को हम यहाँ पे कैसे एक्सप्रेस करेंगे, जो कि Q1 या फिर Q2 के टर्म्स में. अगर हम उसी के टर्म्स में यहाँ पे मान लो कि इसको हम एक्सप्रेस कर लेंगे कि समथिंग इंटू Q1/4πr², तो हम इसके बदले यहाँ पे सिग्मा पुट कर सकते हैं. क्लियर? ओके, सो लिविंग दैट वन, सो इसमें हमें एक लॉजिक यहाँ पे अप्लाई करना है. क्या लॉजिक यहाँ पे रहेगा, जब हम इन दोनों को जोड़ रहे हैं, दैट मीन्स वी आर मेकिंग देम इन कॉन्टैक्ट, तो पोटेंशियल सेम रहेगा. और सेकेंड थिंग, चार्ज डिस्ट्रीब्यूशन में भी इधर उधर हो सकता है. किसी में पहले से ज़्यादा चार्ज होगा तो बाद में कम हो सकता है, तो ऐसे हो सकता है. क्लियर? बट देयर इज नो ओवरऑल इन द होल प्रोसेस चार्ज इज कंजर्व्ड. क्लियर? टोटल चार्ज ऑफ द सिस्टम रिमेन्स कांस्टेंट. यहाँ पे ओवरऑल प्रोसेस में क्या हो रहा है, ड्यूरिंग द होल प्रोसेस, that means total charge of the system remains constant. That means Q total is constant. तो total charge remains constant, that means यहाँ पे हम क्या लिख सकते हैं, तो Q1 plus Q2 will be equal to Q1 prime plus Q2 prime. Okay, so here if we will write, so Q2 instead of Q2 we will write 4Q1, so Q1 plus 4Q1, that will be equal to Q1 prime, let it be like that, plus Q2 prime is 2Q1 prime. So from there what we can write, so we'll write it will be 5Q1 will be equal to 3Q1 prime. Or from here what we can write, so Q1 upon Q1 prime will be equal to simply 3 by 5. Or from here we can write Q1 prime will be equal to 5 by 3 Q1. Clear? So that means directly over here, तो यहाँ पे एक रिलेशन हमें मिला Q1 प्राइम इक्वल टू 5/3 ऑफ Q1. क्लियर? तो अगर ये रिलेशन हमें मिला तो सरफेस चार्ज डेंसिटी जो सिग्मा 1 है, दैट मीन्स हियर सिग्मा 1 विल बी इक्वल टू Q1 प्राइम. Q1 प्राइम जो यहाँ पे लिखा है उसके बदले हम लिखेंगे क्या, 5/3 ऑफ Q1. Q1 प्राइम जो है उसके बदले हम यहाँ पे लिखेंगे 5/3 ऑफ Q1 होल डिवाइडेड बाय 4πr². सो 5/3 इसको हम बाहर ले जाएंगे तो Q1/4πr². क्लियर? Q1/4πr², that is the surface charge density of the first sphere, smaller sphere, before they are brought in contact. That means sigma 1 will be equal to 5/3 of sigma. Clear? This is one standard relation we are getting. Clear? Similarly, how can we find out the surface charge, second surface charge density, यहाँ पे उसको कैसे निकालना है. क्लियर? तो इस वाले पर्टिकुलर केस में अगर हम यहाँ पे देखेंगे, सो ये वाला जो रिलेशन है Q2 prime is nothing but twice of Q1 prime. So if we take this standard relation that q2 prime is equal to twice of q1 prime, क्लियर, इस रिलेशन को अगर हम यहाँ पे लेंगे तो सिग्मा 2 का जो वैल्यू है q2 प्राइम होल डिवाइडेड बाय 4 पाई इंटू 2r square. So q2 prime is twice of q1 prime whole divided by 4 pi. Here it is 4r square, so we'll take I'll take 4 outside and let r square be over here. Clear? So 2 upon 4, so it will be 1 by 2. That means sigma 2 will be equal to half of q1 prime upon 4 pi r square. And over here you can see the value of q1 prime is you can take anyone else. Here in this particular case half, that means half of q1 prime upon 4 pi r square, q1 prime upon 4 pi r square, q1 prime upon 4 pi r square, which is nothing but our sigma 1. Clear? q1 prime upon 4 pi r square, it is nothing but our sigma 1. So q1 prime upon 4 pi r is nothing but sigma 1. Clear? But the value of sigma 1 is how much? 5 by 3 of sigma. So it will be half of 5 by 3 sigma. Clear? So that means the value of sigma 2 will be equal to 5 upon 6. So sigma 2 का value हमें कितना मिलेगा? 5 upon 6. Clear? So that means the value of sigma 1 surface charge density on the first sphere or smaller sphere will be 5 by 3 sigma, 5 by 3 sigma and 5 by 6 sigma. 5 by 2 wrong, 5 by 3 sigma, 5 by 6 sigma correct, 3 by 5 wrong, 6 by 5 also wrong, so 2 by 3 1 by 2, that is wrong. That means option B here it will be the correct one. Okay,